Hello, welcome to Application Analytics for DevOps. My name is Charlie Rich, and I'm responsible for product management at Nastel Technologies and jKool. DevOps is often spoken about as continuous release and deploy, but it's actually quite a bit more than that. And in fact, in some companies, it's even impossible to do continuous release and deploy due to compliance, regulations, and policies in those firms. But let's look at DevOps from a broader perspective. It really sits on the bedrock of application lifecycle management, ALM. This is the entire span from requirements gathering, design, coding, deploy, test, new releases, all the way till the time an application has been sunsetted. What must be done continuously throughout this are three things: monitoring, tracking, and analytics. It's essential to gather the right data and analyze it appropriately in order to continuously innovate and improve and, of course, keep your customers happy. But that's a challenging thing to do because there's a lot of moving parts here that you need to monitor, track, and analyze. Besides the obvious, virtualization and mobile, so many new things have been added. Back in the day, it used to be Java, and it was an N-tier architecture, and N usually meant three. So you had your web server, your app server, your database, and it was pretty easy to see where the problems were and to understand, what to do about them. But that changed. Now things can be in different locations, different geolocations with different rules. We've got messaging connecting it, both cloud messaging, middleware, traditional middleware messaging on premises. We've got cloud services, and we've got this thing called big data. This could be data in motion, real-time data, with a limited lifespan of its value, or this could be data at rest, historical data. Lots of moving parts. And lest we forget, we have the mainframe. Important tidbit here, 70% of all transactions, according to IBM, touch a mainframe. So if you're tracking transactions and you haven't looked at the mainframe side of things, well, you're missing a lot of the story. And also 80% of corporate data is on that as well. So looking at this from the business side, we have the obvious. Our business, of course, their main interest is the customers. They want to make sure they keep them happy, they get more of them, and they retain the ones they have. Tech is there to build what the business needs to accomplish its goals. And ops, whether it's the IT ops or the DevOps flavor, is there to make sure it's all running. So what stops them from doing that? Well, there are three technical challenges here. Their job is to reduce the occurrence and impact from failures. Not so easy to do because while we'd like to be predictive, proactive, and prevent things, stuff happens, failures happen, and you need a plan. You need to be able to respond to reduce mean time to repair and to do that without having to first hold a meeting. Now, the next one is use tooling, but we have lots of tooling. And in fact, IT departments, DevOps groups are continually buying more tools or building their own tools, and yet the problem is still not solved. And this boils down to number three. How do we get the right information to act effectively to a situation? And I believe that sits here. There's a lack of shared metrics. We have metrics about each different silo, each different IT component that we're measuring, but we don't have the picture that explains how they work together and is the application behaving correctly. And instead, we end up with a lot of false alerts. So how do you respond to this? There are three things: monitoring, tracking, and analytics. So let's start with monitoring. The first thing is let's make sure we're monitoring the right things. Let's start with, since we're focused on the business and they're focused on customers, let's start with the customer. What's the customer's experience? You need to monitor end user response time. And you need to tie that to the transactions that are being executed. And then the KPIs are the metrics. So this is all good, but you can't stop there. Now you need to compare it to a couple of things. First off, you have your SLAs, service level agreements, and this lets you know mostly from an IT perspective whether you're meeting your goals. But from an application perspective, it's not enough. You need to understand the business objectives. What is the app supposed to do? And did it do that? Truth be told, most failures are not hard failures, they're soft. It isn't like it just stopped. Did the order go through? Was the trade executed? Was taxes calculated correctly on the shopping basket? Were all of these things done appropriately? You need to know that, and you need to understand what the app was supposed to do in order to evaluate that. So let's take a look now at tracking. So tracking starts off around transactions. So let's define what that is. Transactions, they're the embodiment of the actions the business requires you to do. Why did you build the application? Well, it needs to take deposits at the ATM. It needs to take orders. It needs to issue a trade, on and on and on. Well, each of the operations the business wants you to do can be considered a transaction. They're actual components in your applications. A flow of these together is what we might refer to as a causality chain. And this tells you what happened, in what order, where it happened, and what happened before and after. So this is great for understanding the root cause of a problem in order to reduce mean time to repair. But that's not enough. Next, you need to understand what were the business objectives. We call these milestones. So these are made up of one or more transactions, usually more, and that let the business know that a specific objective has been completed. Think of it as I wouldn't say a logical unit of work, it's a business's unit of work. So here's an example from a trading environment. I think this example here is swaps, and we're looking at trade reporting. So we've got our trade execution. Many transactions are involved in that. Capture, determining rules, enriching, transforming, routing it, getting an acknowledgement, negative or positive. Each one of these is a business milestone. And by completing these, well, then you know you've achieved an objective. And this demonstrates that you understand what the business was attempting to do. And from that, you've got the transactions underneath that. So Nasdaq Autopilot provides all of these capabilities. And same thing is provided in our jKool product in the SaaS world. It provides transaction tracking. In fact, look at the image here. You can see data coming in from IT environments, middleware, where Nastell's historically been renowned for. An important part of that middleware capability is that Nastel can monitor and track transactions across IBM Integration Server, formerly called Message Broker, and also Data Power and mainframes, data feeds. This could be information about money. It doesn't matter. We're monitoring the response of the users and their experience. And here you can see we're doing what's called stitching. We're taking the components of these sends and receives, the different messages, stitching that together into a flow of transactions, and then looking inside the payloads, introspecting, if you will, which helps us better stitch and also helps us better understand if a milestone's been achieved or not. Looking at that data is key in reducing the time to resolve a problem. This entire environment for Nastel and jKool is built on a big data platform for extreme scalability. You can see it's built on Cassandra and Solar from DataStax, which is a NoSQL repository. For messaging, we're using tools like Kafka, and for clustered computing, Spark. All of this is orchestrated by fat pipes, and we're ingesting data from many sources. This could be log data, Log4j, Flume. We could have Hadoop data coming in, Kafka data. We have Java data, Storm, many, and this is just a brief listing of some of the many sources in addition to a RESTful API. But what do we do with that data? That's the important thing. Well, there are a number of services that our product provides. First is time series analytics. Capture that data, order it, compute anything that we can on numeric fields, and understand what happened in what order. Now, interestingly enough, we have both a real-time and a historical grid. So we understand implicitly whether this is real-time data and processed completely in memory, or historical data that we're persisting in our NoSQL repository. We geofence, we convert, we capture, if you will, latitude and longitude, and convert that to human readable forms, country, city, state, postcode, etc. And from that, we can also analyze things in terms of their geo. Most importantly, tracking and stitching, getting the different transactions or messages and stitching them together into a flow. Now that's a good little aside here. One of my favorite TV shows is CSI, and they capture all the facts that you're monitoring. Okay, and we spoke about that. The next thing the detective asked for is get me a timeline. So putting all of those facts together onto a timeline is what tracking and stitching is all about. And that's something we do automatically. To make it easy for the end user to interact with this, we have an English-like query language, and we provide real-time and, of course, historical visualization for that. Another very important point to consider is this. If you only ingest log files, while you certainly can monitor and analyze what's in the log file, if the fact you need to understand isn't in the log, well, then you're out of luck. The beauty of the autopilot solution is that we can ingest data from many sources, certainly log files, but we can capture data from any source. That means that we can analyze and track transactions across all of those data sources. We can look at them as one meaningful whole and determine why things are the way they are. And from that, we can reduce the mean time to repair for problems. A little peek at what this looks like. The English-like queries are very simple. You could just be asking for the get number of events from order and show us a pie chart. Very simple, very English language-like. Now here's an example of that transaction stitching. We've captured this information here about an order, and we've looked at the different components in the applications, and we've tracked the transactions between web orders, verify, credit, router, process payment, ship, etc. All of this was auto-discovered, and this is a flow from end to end. And from this, we can determine why something's failed and also current status. Speaking about analytics, there's a large library we provide of analytical functions, and we're always adding more to this as well. So what does it look like? Well, here's an example. And just for fun, we're going to show you that this can be any kind of data. So in this example, it's sort of an Internet of Things example. We're looking at sports. We have an intelligent basketball that has a sensor inside of it, and we're tracking the movement of the basketball, the shots or throws the players made, their success, how the team's doing, and even vitals about the player, such as their temperature and their heart rate. So here we're looking in a summary view about the throws by player. We've got the Bulls, we've got David Lee, his number. We have a spark line, which shows the trend over the time period, and we seem to have a downward trend. We can drill into this, and now we see the actual throws, intercepts, fouls, catches, etc. We've got track over the data, the specific ball we're talking about, and quite a bit of other analytical data on that. So if we look into this a little more here, now we're looking at a scorecard, and the scorecard is breaking the data up by geo. Remember, geofencing here, and we're looking at the teams and the players, how long they played to a high degree of precision, the number of points, not too good on this guy, and how far away they were when they made their throws. Now here's another example. In this one here, instead of basketball, we're looking at an e-commerce application. And this is an order management app where someone's selling books. And you see here our summary reviews, we're looking at the success, failures, and warnings for a purchase in the order process. And we have our topology view, which is auto-discovered transactions, and then a geo view where we're viewing this geographically. Any of these can be drilled into to see more detail. Here's a comparison where we're comparing events as well, looking for differences. Now, here's an interesting example of something that's called anomaly detection or outlier detection. We're using the math function for Bollinger Bands, which is commonly used in the stock market. Bollinger Bands, the way we've implemented this here, take the event stream that's coming in. We're looking, I think, at elapsed time in this. And what we've done is use an exponential moving average, an EMA, to smooth out the values. Then we create a band above, which is 2 standard deviations above and 2 below. And anytime the value we're charting here goes above or below, we have an anomaly. And this way you can detect an outlier or anomaly without setting thresholds, without writing any rules. It happens automatically. Another tool that we've borrowed from the stock market are multi-panel charts. So we've got 3 different analytics happening on the same time scale. So we've got our x-axis for time. On this panel up here, we're measuring elapsed time for events, and we're using something called candlesticks. These are a great way to see if things are getting better or getting worse. You can see positive trend or negative. At the same time intervals, we're measuring, in this example here, memory. We're looking at how much is being used, etc. And then finally, we're looking at the volume of all events. So you might consider this as, I'm looking at an issue in elapsed time. Well, I want to know, am I running out of resources? And then I want to answer the question of what else is going on and how busy is the system? And you get all of that in each slice. I mentioned earlier about the importance in monitoring and analyzing end user response time or experience. And here's a view of our end user response time dashboard. And you can see here, I'm looking at different countries here, and I've got their status, green, red, or et cetera. That shows that there's a problem with a particular situation. And I can drill into that and get the details. So if you look here, you can see an HTTP request has been broken up into all of its components: app cache, TCP, request, unload, processing, DNS, unload, response, redirect. So we can find where the bottleneck is and deal with that in great detail. If you need more information, please feel free to contact us at info@nastel.com. Thank you.